Here we go. Perfect. Man, 3 seconds. So what are we thinking, guys, as far as, what are you thinking for number 1, man?
C.
Why are you saying C?
Because they're alternate exterior.
Yes, there are. Alternate exterior angles. Nice job, man. Very nice. Coming at you. Okay, hey, my throws are already better than they were yesterday. Yesterday was really bad, just throughout the day. Not my best work. I'll tell you guys, number 2 is one that actually really stumped me. Whenever I was looking over this a few days ago, I was like, man, this one's taking me a second to figure out. If you weren't able to do number 2, I kind of understand it, to be honest. Let me zoom in a little bit here. Refocus. Here's the problem, guys. We kind of have 2 transversals cutting through each other. So we can't just use really one transversal. We're going to have to use both transversals. So press, what do you see if that's 63 degrees? What's that going to mean for R?
It's going to be 60 degrees.
Yeah, those are vertical angles, aren't they?
Mm-hmm.
And guys, I want you to look at your paper. What else are we going to know here? If this is 38 degrees, what else will be 38 degrees?
The one straight across.
The one straight. So are we saying we got some vertical angles? Okay. But guys, there's something else too, right? Vertical angles here, Ron. What else will be 38 degrees?
Wouldn't that one right there, all the way in the corner?
All the way in the corner?
Yeah.
Turn this one right here?
Yeah.
Let's see. Yeah, it would. I'm with you on that.
So then all of them add up to 180, so you do 63 plus 38, and then...
Do you guys see what he's saying here? Do we have a straight line? How many degrees are in all this? 180. So we know we can do 180 minus 63 minus 38. And that'll tell us what that middle angle right there is going to be. Yeah. Oh, okay. Gotcha. What'd you get, man?
79.
79? You guys agree? Let's go. Hey, you guys picked up on that one a lot quicker. I think Jacob pointing out that alternate exterior angle really helped us on that one. Once he realized that we got that 38 up there, it's just part plus part equals whole. That's easily the toughest problem on here. So, Jacob, for finding that alternate exterior angle, that's really what sealed the deal on that one. Nice job. Next up, bada boom, we got number 3. I'm hoping we're feeling pretty good on this one. Let's go, Dave. What are you thinking for number 3, man? What can we conclude about 1 plus 2 equaling 180? What lines can we conclude are parallel? And then what theorem can we use? Okay. And now which lines are we trying to say through this are parallel? Would it be JK or GH? Look at what 1 and 2 are on. Are 1 and 2 on G and K, or are they on J and K, or on that G and H?
They're on J and K.
Aren't these 2 angles, David, on J and K? You see how G is not even being used? So we can't really bring that one into the theorem. We're saying J and K. Yep. How about number 4? Coming at you. He's not even looking. Hit him right in the face. Oh, look at these. I'm dropping dimes right now. I'm the opposite of whatever Sam Darnold is. Well, he's got a terrible team around him.
No, he was terrible.
Oh, well, that's why I said I'm the
Remember his
opposite.
quote from last year on Seeing Goes?
Yeah.
That's my fist. You just don't get that.
Do you even like the Jets?
No, I hate the Jets.
Then why do you want them to get better?
Well, they want to be successful. It's just not happening.
I'm trying to wrap my mind around this.
Let's stop letting them down. So.
Yeah, let's go, Chandler. What are you thinking for number 4, man? Once again, we have we got some angles here. We're trying to find X. He's saying C, guys. That's correct. Would you care to walk us through why, Chandler? Check it out, guys. Jack, if we flip our paper, are these corresponding angles?
Yeah.
Yes, they are. One's inside, one's outside. Same angle. So he's saying corresponding angles are congruent. Set them equal to each other.
Divide 6 to both sides.
Yep, divide 6 to both sides. You get 20. Nice job, man. That was a very beautiful and succinct way to wrap that up. And then last one for our quizzes. What are we thinking on number 5? Open up to anybody here. This was by far the easiest. Let's go, Brody. Help me out. Hey, what are you guys thinking? What are we told about C and B? Those are perpendicular, aren't they? Doesn't that mean we're going to have 4 right angles down here? Remember our perpendicular angle theorem? It says that if you have a transversal and it's perpendicular with one parallel line, will it be perpendicular to the other parallel line, Brody? Yep. Which means all 4 of these are right angles too. They're all 90 degrees. Thank you, sir. Also, don't forget, Brody, while I got you, man, what does it say at the very bottom here we're going to have after on day 5? Just the top.
Chapter 2 quiz standards.
Mm-hmm.
We're on day number 5.
Yep, and you guys can see what the problems are going to be about right there. We always, you guys know, have a quiz kind of halfway through, usually on day 5. So just a little small quiz. It will not go on this 9 weeks. Why do you guys think it won't go on this 9 weeks? Right, number 1, 9 weeks since tomorrow. Number 2, what can end up changing your quiz grade? Your test grade, right? And of course, we're not going to get to our test until the second 9 weeks. I'm not going to put this quiz on the first 9 weeks because if you do really well on your test for this chapter, I want to be able to adjust your quiz grade so it can bump up too. What's up? Okay, so let's go, Dakota Sims. What do we got here as far as our topic's concerned? Oh, shoot. Proofs. We got proofs in the building. Once again. Now, real quick reminder, guys. Real quick reminder as far as proofs are concerned. What are some definitions that we've dealt with that we're going to be seeing again? Mackenzie, what are 4 definitions you see here? And guys, is there math in there, or is that mostly just words? Words. This angle and that angle are alternate interior. This angle and that angle are this. Ethan, do you see any equal signs? Do you see any addition signs anywhere in there? No, because definitions, Jack, what is a definition? It is just it's just a word statement. Yeah, it's just saying, hey, these 2 angles are alternate interior. Now be careful. Remember, definition, we got no words. How about when you have lines that are given to be parallel? So again, we're given to be parallel. You declare one of the 4 relationships, and then what can we establish based off that? These are theorems. Do you guys remember the vertical angle theorem from last chapter? Yeah. If you don't, somebody help. I appreciate Brody being honest there. What does the vertical angle theorem tell us? It says that if these 2 angles are vertical angles, then they are they're congruent.
I know what that is.
Well, guys, guess what? Look at these theorems. Jacob, what are these theorems telling us? That each of these angles are congruent.
Yeah.
So Justin, once again, theorems, we're talking about congruency and postulate. Now, I don't want you guys to include that last one in this. These are talking about congruency. That last one isn't, though. In fact, let's go. Angel, that last one's not talking about angles being congruent. What is that last theorem? Ooh, so that one's not talking about congruency. It's talking about, what does it mean to be supplementary? Yes, ma'am. They add up to be 180. So don't forget, same side interior angle, we're not talking congruency. And then Once again, remember from our quizzes just now, guys? All those converses we looked at yesterday, what was the conclusion of every single one? If we have line T and line V, what do you notice is the conclusion, Dakota, for every single one here? Parallel lines. If you have the converse, then we are saying that all of these are going to be parallel lines. You got it. I'm gonna freeze this up here for a second. Give you guys a chance if you need. It hits the fan. This is where it gets real. Look at what we've got here after I unfreeze the screen. We got ourselves a good old-fashioned proof. Why do you think it looks easy, Jack? You know how to do this? How about, would you care to maybe go ahead and tell me some things maybe we know based off what we're given, Jack?
Okay, I will. It says AC is parallel to DE.
Oh, shoot.
Angle 5 equal to angle 7.
So that's parallel.
That's not
That's parallel to that. And then you're saying DE and AC are,
parallel.
oh, and do we have actually two transversals here?
Yes.
Yes, we do. So immediately we should be thinking, wait a minute, parallel lines, transversal. We got alternate angles, we got corresponding angles, maybe we have same side angles. We got a few different things we could be looking at here. What are we trying to prove, Riley?
I have no idea.
Well, it says it right there.
Where?
Beside the word proof.
Angles 8 and 9.
Angle 8 equals angle 9, yep. So we're trying to prove that this angle is congruent to that angle. And how are we going to do this here? How are we going to do this? I'm going to give you guys a few seconds to kind of look over these steps, and then I'm going to come back to you. We'll talk it out. I don't want to rush you on these. I want to see if our skills from last chapter and some of the new terms we've learned in this chapter kind of come together here. So angle 5 and angle 8. What kind of angle relationship is that, Hunter? Angle 5 and angle 8. Yeah, those are alternate interior angles, aren't they? Okay. How about Brody? What would you say about angle 7 and 9?
They're alternate, are they, are someone like saying alternate something?
Yeah, aren't they alternate? And then are they both inside the parallel lines?
Yes.
Yeah, those are alternate interior too, aren't they? And if that's just a statement, just a word statement, Lucas, we thinking, is that going to be a definition or a theorem? Just words.
Theorem. Definition.
Be definition, my man. Definition. Well, we remember on the previous page.
Hey, go back. What is
I'm talking with Lucas real quick.
Lucas?
All the theorems are about congruency, right? Remember how all the definitions just said, hey, these angles are what they are. Here you go, guys. Definition of alternate interior angles. Just a statement, and I bet some of you guys can already finish this proof off.
Well, the last one's
No.
transitive.
What'd you say?
Last one's transitive.
Jacob's already thinking that last one's transitive, and he's absolutely right. And think back to the vertical definition of vertical angle leading into the vertical angle
Oh,
theorem.
it's a theorem, yeah.
Yeah, if we establish that these are alternate interior angles, using the theorem, what can we say?
Alternate interior. Theorem?
Yeah, we can say that if they are alternate interior angles, they're going to be equal to each other based off the theorem of alternate interior angles. Guys, this is just like the vertical angle thing from last chapter. You have a definition set up what they are. You have a theorem to tell us what that means. And then Jacob, tell us again, man, what are you thinking for that last step?
Transitive.
Transitive. My guy's on the money. And why is it transitive? Because what were we told at the beginning? 5 equals 7. What else does 5 equal?
8.
And then what are we told 7 also equals? So what can we then say?
8 equals 9.
8 equals 9. If 5 equals 7, 5 equals 8, 7 equals 9, then we could say 8 is going to equal 9. Nice work there. Let's go. Before I let you guys try the next one, are there any questions you guys have on this one?
There's the next one?
Well, yeah, this isn't just 2 pages. This is a shorter day, though.
But this one looks longer.
Oh, what have you been doing this whole time? You haven't been texting? No? So, guys, if you're ready, I'll let you flip over to the next page and see if you can try that top one for me. This next one is a lot like the one we just did here, guys.
Yeah, but longer.
Yeah, it's just a little bit. Yeah, we just have to prove one extra thing. Okay, gotcha. You're good. Take a second, guys. Look at what we got here. We know AB's parallel. We know CD's parallel. Guys, if they've already proven that we have parallel lines, didn't converses prove that? So do you think converses are going to come into play at all here if they've already proven the parallel part? No. They've already proven that for us. Remember how, wasn't that what the converse is meant to prove?
Yeah.
We already know they're parallel. We don't need converses here. We're going to stick straight with definitions and theorems. And you guys are going to see that because we're going to have a lot of statements followed by congruency. That's the telltale sign of definition and theorem. So I'm going to let you guys try. I think 99% of us are going to be able to knock this one out of the freaking park. Again, word statements we know mean definitions. The math that follows after that is going to be based off of the theorem. Take a second. So, Angel, what do we see? Second step here. Just a straight definition. And based off that definition, what can we now say about those angles?
It's a theorem.
Well, what are you thinking next, Angel? Yeah. Yeah, because theorems tell us, hey, if based off the definition, we can now say the theorem means they're equal. Who said they got that right? Let's go. Let's go. How about next, Angel? Yeah, if those are alternate interior angles, then we can say, hey. We can say that because of the definition, because of what that means. And because of that, Angel, what can we now say about 11 and 14? So the theorem lets us know they're congruent. And then what was that last step? Transitive. What do you guys think? Are we thinking transitive?
Yeah.
That's right, because what were we told in step 3? Step 3, 1 equals 14, right? What else does 14 equal? Doesn't 14 also equal 11? So what can we say about angle 1 and angle 11? They're congruent. Angle 1 equals 14, angle 11 equals 14. So angle 1 equals angle 11. Let's go. Last one I'm going to let you guys try by yourselves. And then we'll be ready to just about wrap up. It's about that time. I got 3 minutes. So I'm going to let you guys see if you can flex on number 3. Now that we've had a chance to build up our confidence. So definition with the first leads to the theorem. Definition of corresponding leads to, now be careful, this is a postulate. I'm not going to get on you guys for that at all. But just keep in mind that is a postulate instead of a theorem. Yeah, corresponding angles don't have the same exact kind of mathematics behind them that alternate do, so we just use a postulate for that. And then because of that, again, don't freak out. If you had put corresponding theorem there, I would not have counted that wrong, by the way. I would not have, I promise. If we say 2 and 7 are equal, and we know 2 and 10 are equal, then what can we say about 7 and 10? Transitive. Right. Remember what I said, that was the last one. So transitive. And give me a reminder, Bree. Thank you for the heads up, though. Yeah. Ooh. No, hey, no. I told you. I told you to, Bree.
Totally.
No, you got. I appreciate that, Bree. Precious is over there trying to stir it up a little bit. I see you. So, guys, part 2 is going to be a 5-minute video I put out. Look, yeah, well, because we still have page 4. So look for that in second period. I should have that out for you guys.